Dear students, in differential calculus, you might have learned about limits and continuity, that is all. On one more topic is differentials or derivatives. Differentials or derivatives, how we have solved, we adopt few techniques, and those techniques, once you are clear with the concepts, then it is easy and find it so simple. Supposing if you are unable to solve any kind of problem without having the fundamentals and basics, it is much difficulty for you to solve. But this one in exercise 10.4, the last exercise of differentials, this is like a successive differentiation. Successive means differentiation, we are differentiating once, twice, thrice, 4 times, like that. Have you give some example for 1 derivative, 2 derivative and 3 derivatives? Let me give example for first derivative. If you have a coffee, you had coffee this morning, but when you had a coffee this morning, what and all you could identify? First, the byproduct. What is the byproduct of coffee? Main thing is the seed of coffee. The coffee what we had is a function, that seed is nothing but f of x, and when we make the same seed by roasting and making this one as a powder, that is derivative, first derivative. Once again we make it the same coffee as what we drink as a hot drink, coffee, that is second derivative. So, it was modulated, it was that it is a transition. First one, it is a seed of coffee, the function f of x. Second one, there is a powder which we make, that is a coffee. Then we second part, like that when we go by this second derivative. Third derivative, how we are getting? When if you are going by bus or car. So, by way of seeing another vehicle going to get an accident, by then the driver apply this brake. Sudden brake, we use it, call it as jerk. By then what happened to the car or the vehicle where while you are traveling, you get a jerk. That moment is called jerk. That jerk is nothing but third derivative. Now, I have narrated all the 3 things for your information. First, what is derivative and what is a counter example for first and second derivative usage of coffee, and third derivative, it is a vehicle that you travel when the driver is applied a brake, even though the speed is going on. Remember that the simultaneously speed also keep going. So, by then they applied brake, the jerk will happen. So, that is what it is, third derivative. Now, the successive differentiation also like that. So, each function will keep on deriving. Here what is it? Y is equal to sin inverse of root of 1 minus x square. Prove that 1 minus x square y2 minus 3 xy1 minus y is equal to 0. The successive differentiation, you should know first what is successive. Successive differentiation, any function y is equal to f of x, while you are differentiating, we may call it as dy by dx, that is f dash of x. In other words, it is y1, in other word it is y dash, in other word it is y naught, In other word, it is d of y. We can give a different name for derivatives, dy by dx, f dash of x, y suffix 1, y dash, y naught, capital D of y here, capital D of y. And second derivative, d square y by dx square, f double dash of x, f double dash of x, y2, y double dash, y double naught, and d square of y. Likewise, we can do any number of differentiation, each one name it like this: dn x y power dx power n, fn of x, y suffix n, yn double, yn naught, that is y naught nth term, and d of n of y. So, this is the way the successive differentiation can be narrated. Here, what is this y1 and y2? That means first derivative and second derivative only given here. That means 2 times the function is differentiated. You should know about it. Then only you can go with this sum. Otherwise, it is much difficulty for you, because you do not know what is y, what is y. Y is the function, but the y1, y2 means 2 times the function is differentiated. Okay, now y is equal to what is given, sine inverse of x over 1 minus x square. Sine inverse of x over 1 square root of 1 minus x square. You cross multiply. So, y into 1 minus x square equal to sine inverse of x. So, here what you can do, here y, here 2 functions, here only 1 function. Something we must do to arrive this answer, for which what you can do, here square root is there, that is a difficult and disturbance for us to do any kind of manipulations or even differentiation. Differentiation we can do, but the terms keep rotating. Instead, what I can do, in order to make the sum is simple, so I can do with this, that is with squaring, better, on squaring. What does it mean? Squaring on both sides, that is y square, that is 1 minus x square. The square root will go sine inverse x the whole square. Remember that. Like this the term exists. Now you can differentiate. Now the function like this, now you can differentiate the function. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. That means here this is nothing but u and this is v, and u and v here. That means u keeping holding u, differentiating v, better, plus holding u, holding v, I am sorry, holding u differentiating v and holding v differentiating u. And this one also we are differentiating. Now, this is the simple manipulations, simple calculations that you can do. 1 minus x square, what else? Minus 2x. Here 1 minus x square as it is, and y square differentiation. Y differentiation is y1. Remember that y is y1 and y1 is y2 and y2 is y3 like this. Here y square is 2y into y1. Remember that. N x power n minus 1, then once again y is differentiation is y1. Here sin inverse x. See, the sin inverse x is nothing but 2 into sin inverse x of, that is n x power n minus 1. Then once again the sin inverse x become, that is function of functions, 1 minus x square. Remember that. Like this we can do. See what I have written here, very simple for your reference. Y square minus 2x, 1 minus x square, 2y y1, 2 sin inverse x. Sin inverse x is 1 by this. Here we write in order here, that is nothing but 1 minus x square 2y y1 minus 2x y square equal to this 2 into sin inverse x by root of 1 minus x square. So y is equal to sin inverse x by square root of 1 minus x square is what? Nothing but y. So you can apply y over here. This is nothing but y. Sin inverse x divided by root of 1 minus x square is y. That means 1 minus x square 2y1 minus 2xy square like this. So now this problem we have come to almost the conclusion like. So this is the format that we got after doing differentiation and then application of the term of y, everything we found out. Now cancelling everywhere by divide by 2y. So here remember that 2y 1 minus x square 2y y1. Here what else? 2y y1 minus 2y y1. Remember everywhere you cancel 2y. Remember that. Here 2y, here 2y, here 2y. Remember, wherever 2y is there you cancel it. And everywhere you cancel by 2y, what happened? 1 minus x square with y1 minus, so cancelling y, 2y, xy equal to 1. This is the way we found out now. Cancelling everywhere by 2y, this is the one exists. Now once again you have to differentiate, because problem is 2 time differentiation, successive differentiation having second time we have to differentiate. So that means this is the derivative of 2 times. So first time only we have done. So do the process again, continue to do that. So here everywhere we cancel, so 2y can cancel like that. Differentiate again. Once again we have to differentiate. This is u, this is v, this is u, this is v. 1 minus x square and then y2. So y1 differentiation is y2, remember that. Then differentiation of, otherwise because you may be finding it difficult, I can write like that, and then y1 and differentiation of 1 minus x square minus x with dy by dx plus y with 1, and right hand side differentiation is 0. Like this you can do, so that it is easy for you. One differentiation is 0 here, and this part 1 minus x square, y1 differentiation is obviously y2 plus y1 bracket negative 2x minus x y1 plus y equal to 0. This is minus part. Remember that the minus I put bracket here, 1 minus x square y2 minus 2x y1 minus x y1 minus y is equal to 0. So, 1 minus x square y2, these two are like terms, minus 2 minus 1 minus 3 x y1 minus y equal to 0. So, here we find the answer, and this is the final answer for the problem. What we want to prove, we have proved, hence it is proved. So, this is the way we found the solution for this successive differentiation.